Hello students, today we are going to see Sn1 mechanism, that is nucleophilic substitution unimolecular reaction mechanism. Already we have gone through Sn2 mechanism, Walden inversion, inversion of configuration and favorable conditions for the Sn2 mechanism. All those points we have gone through that. I would like to tell you one point here. Learning means from known to unknown. Already you knew the mechanism, what are the conditions for the mechanism, how the reaction takes place, what are the steps to be followed. All those points we have gone through. This point is in one mechanism. It's so simple and easy, more than Sn2 mechanism. What are the reactants in that Sn2 mechanism? Here, methyl halide combined with aqueous potassium hydroxide while heating, you are getting methyl alcohol. That stepwise mechanism we have gone through. How that nucleophile which is going to attack from backside or front side, those points and all we have gone through. The same way here, methyl halide only, but what methyl halide? That is tertiary, that means one carbon as attached with three bulky groups. The tertiary butyl halide combined with aqueous potassium hydroxide, you are getting tertiary butyl alcohol. This is a simple reaction for that Sn1 reaction. Now we are going to see how the reaction takes place in a stepwise progress. We are going to see to that. Okay, now here this methyl tertiary butyl bromide combined with potassium hydroxide, aqueous potassium hydroxide while heating, you are getting butyl alcohol. That is OH minus acts as a nucleophile. This nucleophile which is going to replace that leaving group and which is going to attaches to that carbocation. That point we are going to see to that. Now, in this reaction, the bulky group attaches to the carbon connected with the halide ion. Now, this OH minus ion, usually it will go and attack behind. But in this reaction, which is not possible. Why? Because the bulky groups attaches to the carbon. That means soldiers are available. Three sides also soldiers are available. Carbon has valency 4. Now in the three sides are big soldiers are available, big bulky groups are available. So this OH minus nucleophile cannot go and attack behind. Only one door which is available, that is bromide ion, that only can go and attack. So here the OH minus ion directly it will go and attack the halide. For that you are getting two steps reaction. One step, it is a formation of cation, that is carbocation. The other step, it is nucleophile is going to attack the carbocation. So these are, now we are going to see the two steps process. Before going to see the two steps process, I would like to mention here steric hindrance. What do you mean by steric hindrance? The bulky groups attaches to the carbon containing halogen attacked by the nucleophile. The nucleophile which cannot go on attack from the behind, where there is opposite side the halogen atom attaches. No, the nucleophile cannot go and attack. Only the front side which can go and attack. Why? Because the bulky groups are attached to that carbon. So that is the reason nucleophile can go and attack that carbocation. Yes, fine. So that point it is called steric hindrance. These points and all hindered, that means hide. So that is the reason they mention steric hindrance. They may ask one more. In the two steps process, first step, formation of carbocation. Tertiary butyl bromide undergoes ionization. So automatically bromide ion has removed. So you are getting what it is, carbocation formation. That is what we required. So we got that carbocation. That is actually, what is it? Planar structure. Now the second point, yes, that the carbocation, it is getting ready to get that attacked by the nucleophile. Already nucleophile also it is ready only. So here OH minus ion, it's going to attack that positive charge of that what it is carbocation. Then finally you are getting what it is CH3, C here CH3 and CH3 OH formation. So this is tertiary butyl alcohol formation takes place. Hope you're clear with it. Okay, now here, what are the points to be noted? Yes, let us go for the points to be noted. The first point here, as I mentioned, it is formation of carbocation. The first step, it is a slow step reaction. So, slow step reaction means that is a rate determining step reaction. The second one, the rate of the reaction. The rate of the reaction depends only on the concentration of alkyl halide. It does not depend on nucleophile. So, only one reactant it is possible to give for the rate of reaction. So that means it is a unimolecular reaction, that is a first order reaction Sn1, that is what it has mentioned, nucleophilic substitution 1 first order reaction. Now that next one, rate of, since carbocation forms the rate determining step. Now, stability depends upon the rate of reaction. Now, stability is directly proportional to the carbocation. As that higher the stability of carbocation, higher the rate of reaction. Higher the stability of carbocation, higher the rate of reaction. So, carbocation, it has to be increased. That means the concentration depends only on the alkyl halide. From that only you will come to know this point. Yes, stability is directly proportional to that carbocation. Oh, the next one, stability of the carbocation in order. It is a tertiary, secondary and primary and methyl. Just the opposite of Sn2 reaction. Sn2 reaction, methyl, primary, secondary, tertiary. But here tertiary, secondary, primary and methyl. So that is the reason. Okay, now the next one, polar solvents are used for Sn1 mechanism. Hope you're clear with it. If you want, you can take that screenshot. The next point, we are going to see some give reason questions related to this point. Thanks for watching. Here, I would like to give some important steps to be noted for Sn1 and Sn2. Sn1 reaction, there are two steps reaction. Why? Because slow step, rate determining step and fast step. Whereas Sn2 reaction, it is only one step reaction. And concentration, Sn1 mechanism, concentration depends only on the alkyl halide. Whereas Sn2 mechanism, here alkyl halide as well as nucleophile. These are the points to be noted, and some more points I would like to give on my next video. What are the difference between Sn1 mechanism and Sn2 mechanism? Very clearly I would like to give that my next video, and I would also mention about that some important questions related to Sn1 mechanism. Hope you're clear with this.